Hello, all. I'm back again with another episode of Mr. Mitchell Does Trigonometry. In this case, we're working with Pythagorean Theorem. Questions 161 through about 170 here. It is Pythagorean Theorem, and they're wanting us to simplify the radical instead of giving a decimal answer. So what we're going to be doing here is we're actually going to try to leave things in radical form as much as possible as we're doing this. And I know at least a few of you have expressed confusion because there are radicals in the problem, given as legs or the hypotenuse. That doesn't really change how you deal with it, but it can be a little confusing when you first get started here. So what I'm going to start with, I'm going to start on problem 161 here. And just checking there, I've got the hypotenuse as one of the ones I'm given. So I'm actually going to be subtracting the leg, or the squared leg, from the squared hypotenuse. But you can set it up like normal if you want, which is x squared plus the square root of 7 squared equals 2 on the square root of 3 squared. Now, anytime you're squaring a square root, those two things are going to cancel each other out. So in this case, that square root and that 2 are going to cancel each other out. And I'm going to be left with x squared, let me change colors here, x squared equal, or plus, can't talk, 7. Because square root of 7 squared, that would be the square root of 7 times the square root of 7. And I can do it over here to the side. Let me do it in green. So I got the square root of 7 times the square root of 7, which is the square root of 49. 49 is a perfect square, which is just 7. So what happens is that radical gets canceled out with the square, and you're just left with the radicand. That's the number underneath. Equals, similar thing here, except I got to remember that I've got to square the number out front as well as that. So I get 2 squared, which is 4, times square root of 3 squared, which is just 3. So 4 times 3 is 12. So I've got x squared plus 7 equals 12. Now, inverse operation, subtract 7. I get x squared equals 5. Take the square root of each side. I get x equals the square root of 5. All right? And this, anytime I take a square root with that and get rid of that square, it is potentially plus or minus the square root of 5, but in this case, because I'm not dealing with imaginary numbers, I don't have to worry about that as much. So I've got x equals the square root of 5. All right. Let me do another one here with the radicals. I think the ones without the radicals we're okay with, but let me do another one with the radicals here. Let's look at 163. And on 163, if I do that, x is my hypotenuse there, so what I have is my 2 legs. So I've got the square root of 5 squared plus the square root of 11 squared equals x squared. Or I could just write that as x squared. All right. Again, reminder that square roots, my radicals here, my square root with a square, those guys cancel each other out. So I'm actually going to be left with 5 plus 11 equals x squared. I'm going to go ahead and combine those. That gets me 16 equals x squared. We take the square root of both sides, and that actually gives me x equals 4 as my hypotenuse there. All right. Let me look and see what we've got here. Okay, and one more here, because there's at least a couple here that you're going to have to simplify the radical. So I'm going to clear some of this stuff out. One such as that is going to be number 167. The first thing I'm going to do on 167, find my hypotenuse, which in this case, draw my line through it, gives me 15 as my hypotenuse. So I'm going to come over here and set that up, and that's the square root of 65 plus x squared, I forgot to square my square root of 65 there, sorry about that, equals 15 squared. So a squared plus b squared equals c squared. Now, if you'll remember, the radical and the square cancels each other out, so I'm left with just 65 plus x squared equals 15 squared is 225. Inverse operations, I'm going to subtract 55 from both sides. 65. Goodness gracious, can't talk today. Subtract 65 from both sides, and I'm left with x squared equals 160. Now I'll take the square root of that. X equals the square root of 160, except square root of 60, I type that in my calculator, and I don't get a nice number. It's like 12.2 something or something along those lines. But it says in simplest radical form in the direction, so we actually have to simplify that. Now, the easiest way I showed you how to do this was to break it down into your prime factorization. Sorry, had a mind blank for just a second. I was trying to find me a new color over here to play with. Do prime factorization. And when you're doing that, what you're doing is you're trying to split this up into its smallest numbers possible, down to where you have nothing but prime numbers. And it doesn't matter what you start with. Since I see the 16 there, I know 8's going to go into it. 8 times 2, but it's 160, so it's going to be 8 times 20. 8 will break down into 2 times 4. 2's a prime number, so I'm going to go ahead and circle that. Break the 4 down into 2 times 2. Those are prime numbers, so go ahead and circle those. 20, 2 times 10. So 2 is a prime number. Break the 10 down into 2 times 5. 2 is a prime number. 5 is a prime number. All right? Now, if you recall, and if you don't recall, it's still true, when you're doing the prime factorization here, for every one of those that you find that you have a pair of, you can bring outside the radical, because that's essentially saying you've got that squared in there. So 2, I can bring a 2 outside because I had a pair of 2's. There's another pair of 2's, so I can bring it outside. And if I look, I'm left with a 2 and a 5. I don't have a pair of those anywhere. So what happens is they're going to stay underneath the radical. And 2 times 5. Now I'm going to go ahead and simplify those. 2 times 2 is 4. And 2 times 5 is 10. So what happens is x equals 4 on the square root of 10. All right. That's simplifying radicals. That's Pythagorean theorem. As always, if you have more questions, don't hesitate to reach out to me if this wasn't good enough to help you out, and I will do all that I can to help you out. Just a reminder, due dates, those are just try to keep you on track. If you don't get everything done today, you work on it Saturday, Sunday, whatever. Just know new stuff's coming out Monday. So hope you guys have a great weekend. Stay safe, stay at home, go outside, have some fun, and I'll talk to you guys again soon.